Hello everybody. My name's Mark Davis. I'm a Passive House certified building designer based up here in the Blue Mountains, and today I'll be helping a couple of my colleagues present to you their flame zone and sustainable houses. Just before we kick off, so they can tailor to the audience, I'll just find out who's here. I know we have the one architect representative, and I think we have the 3 building designer representatives here. No one else has turned up. Planners. BPADs, lots of BPADs, building certifiers, cool. And who have I missed? Builders, the most important. None of this is going to happen without you. I'm so sorry. Jeez. Yeah, I know. It's our job to make your life hard. Okay, so first of all, Kirsty's going to present her project to you. Kirsty Wulf's a building designer with a passion for natural, healthy, sustainable buildings. She became interested in hempcrete through owner building one of the first hempcrete houses in Australia, and has gone on to become one of the leading advocates of hemp building in the country. She's based up here in the Blue Mountains as well. Her work combines her experience with natural building materials, building in bushfire-prone areas, building science, and she's also a Passive House certified designer. So I'll hand over to Kirsty.
Thank you. Thank you, Mark. Thank you very much for that introduction. The project that I'll be talking to today is a project at Blackheath in the Blue Mountains here, and it's a BALFZ project. And what I'll be talking to you about is primarily looking at the walling material that we used here, which is in fact hempcrete. So I'm assuming that a lot of you don't actually know what hempcrete is, but over the next 20 minutes, you will all be experts. So here goes. So this is the place up at Blackheath, and fantastically, it was also featured in Sanctuary magazine. They did a hempcrete special. And there was actually a profile on this very house. So that was actually last issue. So sorry, it's out of the newsagents now, but well worth a read because they are a magazine focused on sustainable buildings. So in terms of this particular project, it's on a block of land that is actually facing some national park. And during the 2019-2020 fires, there was actually back burning directly up to across the road from this building. It's a small house, which is actually quite sustainable. Building smaller means less materials. And there's just some information in relation to the house. But look, let's start off by looking at what in the world is hempcrete. Okay, hempcrete is a combination between the hemp fibre and a lime-based binder. And so when I'm talking about hemp fibre, I'm not talking about the stuff that your shirts or your sheets are made out of. That's the outside bast fibre of the plant. I'm actually talking about the inside fibre. So it actually looks something a little bit like this. Actually, it doesn't look a little bit like this. This is it. So it's basically quite a sort of a woody type fibre, but it also has a hollow core to it. And part of the hollow core is the key to its good insulation values. Now, I've also got a little bit of show and tell. So we actually have a couple of samples of the hemp hurd that we use for building. This is one from Australia and this is one from Europe. So feel free to have a look at it. You can open the bag, touch it if you like. This is all industrial hemp, so low THC. Don't even think about smoking it. So what actually happens to that is that at the moment, it looks a little bit like bark chip, and you think, well, how are you going to make a building out of that? But basically, it's mixed with a lime-based binder, and it will form a solid material. And most of the buildings are cast on site, so you can actually have a look at this. you can actually feel it's quite lightweight, yeah, this is so that's our hempcrete. So why in the world did we start building out of sort of fibre and lime? Now, basically, it started back in the late 1980s in France. They had these wonderful half-timbered houses, but they needed sort of renovation and improvement. And they'd been using concrete-type materials, and that had actually caused the timbers to deteriorate because concrete is not vapour permeable. So they needed a material that would provide high insulation, but also provide vapour permeability and to keep that moisture away from these timbered houses in order to preserve them. So they started doing that with the hempcrete. There's also a hempcrete house in Japan, which is about more than 300 years old, from a hemp growing region. So while that's an older example, it really came from France back from the 1980s. So I'm primarily going to be talking today about its fire-resistant properties because that's what we're really interested in, but it's not a material that is actually marketed as fire resistance being its primary property. It's a really good insulator. So we're looking at a 300 mil thick wall would give you an R value of 4.2. So the lambda value, for those who like to know, it's 0.03 to 0.55, which is really quite low. So good insulation. Now that comes about because a number of things. As I was talking to you about that, the fibre is hollow. So there's air trapped in that fibre. There's also air trapped between it and the fibre itself. So another thing is we've talked a lot about condensation in buildings and the importance now for buildings to be vapour permeable. So the hempcrete is naturally vapour permeable. It's also termite, vermin resistant, non-toxic, regulates humidity. So it's a building material that has a lot going for it, and the non-combustibility of it is actually kind of a bonus. We're also looking now a lot at the carbon impact of our building materials. Now, this is something where hempcrete really comes into its own in that it actually has a less than zero carbon impact. So there is more carbon stored in this material when it's used than is produced in its manufacture. And most of that carbon actually comes from the lime. And yeah, hemp is a very fast-growing crop. It will only take 3 to 4 months for the crop to grow. So if you think about comparing that to something like timber, which takes 25 years, you can see that's much more beneficial. The other thing is that the hempcrete, it's quite compatible with standard building practices. So I work in the natural sort of building space, and a lot of other materials such as straw bales, mud brick, rammed earth. It's a lot more difficult to do things like get your services through and those sorts of things. So the hempcrete is really quite compatible with standard building. So how in the world do you use this material? So the most common methodology is for it to be cast on site. So that means that there's a formwork, and this is actually the house up at Blackheath. There's a formwork that is held out from a standard timber frame. The hempcrete is mixed in a flat pan mixer, and it's poured into that formwork. It's then lightly tamped down and it will go off. You can actually remove the formwork the following day and keep going up. We tend to build in about 600 risers because that's kind of convenient if you think about sort of your arm length and how practical it is to build. Services go in first, so nice and easy in terms of construction. Now, the thing is also, from a bushfire point of view, our timber frame is encased in our non-combustible material. So both from an inside and outside, we're protecting that timber frame. The reason we have a timber frame in there is that the hempcrete is non-structural. Now, it's non-structural because it needs to be light to have a good high insulation value. So this is the house up at Blackheath. There's our mixer. Yes, lime is caustic, so we do have to have our mandatory PPE on there. And in terms of that, with the design, a hempcrete house can look however you want it to look. In this particular house, we did some very nice sort of curved window sills, but because it's cast in a formwork, whatever shape your formwork is the shape your building will be. So you can do all sorts of creative things if you want, and that's how we got these beautiful soft curves on the window sills. The windows there are the Parhammer Bell FZ timber windows. So primarily in Australia at the moment, we are building with the cast on site, but there's also hemp blocks. There's about 3 companies in Australia, 2 of them selling imported blocks and one of them selling Australian-made hempcrete blocks. And there's also a couple of companies doing spray installation. They're just trying to sort of speed up the process, because one of the downsides at the moment with the hempcrete is that it is quite labour intensive. So just having a quick look at the construction of a hempcrete wall, we can see our timber frame through the middle, our hempcrete around it, and it's finished with usually a lime plaster on the outside, and it can be clay or lime on the inside. That adds to the fire resistance of the material. It needs to be vapour permeable, because if you've got a vapour permeable wall, you've got to make sure your finish is a vapour permeable as well. In terms of fire testing, there are a number of commercial products available on the Australian market. So the Tradical hempcrete, which is a product which is imported from Europe, it's distributed in Australia by OzHemp. They have done testing on that, and their 300 millimetre thick wall got a 60-60-60 rating, which, as we know, Bell FZ's only 30. So we've well and truly sort of exceeded that. The Australian Hemp Masonry Company, they've actually only tested theirs to Bell 40. I'm quite confident that it would, in fact, perform to Bell FZ, their product. They just haven't. They don't have a large enough market in Bell FZ to justify the cost at the moment for that testing. So in terms of that, there's been quite a lot of research, primarily from Europe and the UK, in terms of the performance of hempcrete. And we have here, this is just some thermal imaging showing a blowtorch on that. So the flame in that one is 1800 degrees, 10 centimetres away for 10 minutes. They put that on there. I mean, this is just a trial sort of test. The surface got up to 165 degrees, no ignition, no spread of fire. And most importantly, though, it stays cool on the back side of that. So this should be a video. It's a video. This is a video from a test in New Zealand. It's not actually it was just a rough test. So what they've done is they've got their blowtorch on their hempcrete block. You can see the timber frame. What's important, though, is if you have a look here, when they go around the back, it's really cold on the back. So we're not getting any heat penetration through the material, which is quite important in terms of, people are using that material to sort of shield in their house. The initial temperature on the outside of that was actually a lot hotter, but I talked to the guy who did that video, and he said that his thermal imaging camera only went up to 120 degrees. So that's why that was the maximum temperature there. But you could see how on the backside of that, 8.1 degrees after we've held a blowtorch against that material. So in addition to no combustion, we also have the insulation properties of that material. In terms of larger testing, they also did a full-scale 2-storey test in France. Interestingly, in this particular test, they actually had timber windows, and they simulated a timber first floor in this building. When you talk about sort of cribs for testing, they put some serious sort of amount of timber in there. and lit that up. This was also a rendered wall, and that additional layer of render provided further fire protection for that wall. Sorry, if we wait a few more seconds, we'll actually see the flames going up, I believe. There we go. So the windows, the timber windows completely go, the timber first floor completely goes, but the hempcrete wall is still standing there, not combusted, and still in place. So there's our fire. So in terms of testing, I'd say that's a success. So it's proven itself in terms of its non-flammability, but the benefit of this material is also that it has environmental benefits and thermal benefits as well. So I think that we're satisfied that we've seen some flames now. It's always good at a bushfire conference. So yeah, just sort of useful to know that. So in Australia, then having a look at, I think we can. Oh, sorry, I'll go back now. Oh, sorry. Okay. In terms of bushfires in Australia, this is a hempcrete building down at Nelligan near Bateman's Bay in the south coast. It got hit in the 2019 fires, and the owner of this particular place did actually stay and defend, and the flames came up close to the house but didn't directly impact on the building. But the owner was confident that if they could not stay outside and defend, that their plan was to shield inside the building because of the non-combustibility of the walls. Interestingly, the building was actually only built to BAL 19 because that's all the requirement was. But I mean, it was a serious fire there. The neighbour's house got burnt down, so there were certainly risks there. Then there was a fire in 2022 at Bridgetown in Western Australia, and a hempcrete block factory got hit. Talking to the owners, they actually got hit twice. The fire came through, the fireys came down and wet everything down, and then the wind changed and the fire came back through again. What we're looking at here is those blocks in the foreground were not cured. They hadn't dried, so they still had moisture in them. And so you can see that there's been some fire damage to those blocks. But the blocks in the background that look perfectly good, they also went through the fire. They were stacked on a timber pallet. The timber pallet underneath them completely burnt out, and they've just moved those blocks completely undamaged. So that's sort of, in some ways, very much a real life bushfire test to actually see how these things would go. In terms of hemp houses, they can look contemporary, traditional. You can clad them, but of course that would avoid the bushfire benefits. Another one of the great benefits about the hempcrete is that really seriously reduces your thermal bridges, which is great for the thermal performance of your house. In terms of building approval, generally it's not obviously a deemed to satisfy, so we generally get approval through performance solution. The AusHemp Tradical one, which I showed you the first in the fire ratings, it has a code mark certificate. So that makes it nice and easy, and that code mark certificate shows the 60-60-60 rating for that. Makes it nice and easy when getting your council approval. Sorry? Yep. The alternative way is basically by just a standard sort of performance solution. So the Australian Hemp Masonry Company, their product, they provide a performance solution report that will allow you to get approval for that. Yep, so if people are interested in looking into it further, there's a lot of great material out there on hempcrete. There's a couple of these two up here, hemp and rice husk-based concretes for building envelopes and bioaggregate building materials. They're kind of the techie things. So if you're into the technical kind of things, you really want to see how it works and the performance of it. Fantastic resources. The other books are just some sort of general sort of building information. First one's from the UK, Essential Hempcretes from Canada, and the other one's from the UK as well. Hemp Building's 50 International Case Studies, just goes through and looks at different hemp building around the world. I was lucky enough to get one of my buildings in there too. The other thing is that, look, hemp building in Australia has been around for about 10 years. Probably more than 10 years now, 12 years now. It only really started once we actually had legislation to grow industrial hemp, because we needed to have that material available locally. So after the Hemp Industry Act came in New South Wales in 2008, things sort of started slowly. If you are interested in building with hemp and you're trying to find builders or designers, or if you're a certifier and you've worked with hemp, please go on our directory. Myself and a colleague, Jeremy Thomas, have set up this hemp building directory just to kind of sort of put it out there and link up all the people who are working in this industry. So please go on and, hempbuilding.au is the tagline for that. So feel free to go on and have a look at that. And if you have any further questions, there are my details. Please feel free to send me an email or have a look on there's also a Facebook group, Hemp Building Australia, to promote that. So that's our Flame Zone Hempcrete house at Blackheath. Thank you.
Thanks, Kirsty. And we're going to do questions at the end of both presentations. So next we have Cory Webb. Cory's worked in bushfire building design space for about 10 years. His studio combines building and landscape design to ensure a coherent design between the inside and outside environment of their projects. He's an active member of the Building Designers Association of Australia. Since this house was designed, he has also become a certified passive house designer. We're trying to take over the world, in case you hadn't noticed. Welcome, Cory.
Thanks for that, Mark. So taking a bit of a different tact with this one, we're looking at a passive solar design flame zone house. So the overlay of sustainability and bushfire, and then using a lot of strategies that we're familiar with. Craig Burley helped us a lot with this. Thanks, Craig. And we also had a lot of help from the builder, and had a mentor of another architect who gave us a lot of wisdom. So happy to share some of the wisdom that they shared with me. As I said, just 10 years in the bushfire sort of space. So looking at what influenced the design, if we have a look at our first, this is a house. Looking at what influenced the design, that's the brown one in the middle, you can see it's in Glenbrook, a steep drop off. It's about an 8 metre drop from front to back. Views out to the national park, and there's some cliff formations through the property as well. So we really wanted to try and keep as much of what we could in the natural landscape. Views out to the national park as well. So we wanted to take advantage of those views in the design. The topography, this is just a section through the house. The existing house was cut into the block quite a lot. So we didn't want to expand the footprint of that house and do a lot of excavation of more rock, but just try and fit within that footprint as well. So that would save on costs, but also work into the idea of working with the natural landscape, not against it, in sustainability. We had a flame zone rating, and then we used a shielding provision on the west side. So that's the carport side for about 40. There was also some planning, some planning constraints. We had a 5.5 metre height limit with view sharing considerations from the neighbouring properties. So we really want to make sure that it fit in with the context of the area as well. And then sort of considering that it's not poking up high above the neighbouring houses. Next consideration was solar. So the view was west, and that's where you get all your hot afternoon sun. And the slope was going down to the west, as you can see in the image here. So it was really highly exposed to a lot of heat, but then also a lot of bushfire. But we wanted to take advantage of that. We wanted to be able to get all those views with living spaces and bedrooms so it would work well. So to achieve that, this is the entry level, the ground level. So we come in on the deck into the dining, and this is the view through there, taking advantage of those views through, and then from the ensuite at the other end of the house with an outdoor bath, looking outside there. Not really going to help with the bushfire, but nice to sit in nice weather. Downstairs we also had all the bedrooms and living spaces facing west for that view as well, and there's a shot from inside. The style, the client didn't want something that was going to be like so out of context with the natural vegetation in the area, and also that would fit in with the topography of the space. And we originally designed it with these folding Corten screens on the front. COVID hit and we didn't end up with those, but we had Corten standing seam that we used on the external cladding. So then privacy was dealt with internal blinds. So it's a lot of glass in a bushfire area. How did we deal with that? And also take advantage of all the views. So obviously bushfire shutters came into the picture in a big way. And here's a shot sort of showing the two levels on the side. So it was really couched in the topography. And then also worked with the sort of natural colours that would fit in with what was around. So the reflection of the glass obviously helped with that. Going to specific bushfire design strategies that were implemented. So on the ground, the lower ground level, we can see we've got very highly durable concrete block construction with stone cladding on it. And so ember attack and the like would be on a very durable sort of base. Upstairs we used the James Hardy wall system and put the Corten look aluminium cladding from Vitrolock over it. And then also this bottom right bedroom, we had the RFS bushfire tank built under the floor of that, which was oversized, and then access off the side. And we can see set off from the house is the pool, which was to act as another natural defence mechanism in the bushfire design strategy. So then how did we, going back to that question, how did we address this west-facing sun? How did we address the bushfire threat and getting adequate solar access into the house? So we used it through oversized eaves upstairs, and then the building form downstairs was these deep recesses with articulated windows. Did a lot of detailed sun studies to make sure that we got lots of light in winter and blocked it all out in summer. And so the size of all these were finely tuned. In section, what that looked like was on the upstairs off the terrace, we designed a pergola that sat underneath the roof structure, and the bushfire shutters were encased in that pergola structure. So they're effectively hidden. And then downstairs, as you can see, we've got the rumpus room bedroom and the concrete block construction. But then in the soffit of that sort of colonnade or recessed space, we put the bushfire shutters up in there. So how did that look during construction? You can see we've got the bushfire shutters being installed here, and that Core-10 pergola wrapping around. And then it might be a bit hard because of the dark ceiling, but you pretty much can't tell where the bushfire shutters are and when they start and stop because of the continuous Core-10 pergola around the top. So this, obviously along this door, is all bushfire shutters, which will open up into there. Then downstairs, how did we do that? So like we mentioned in the section, we built the roller shutters, the bushfire shutters up into the soffit. And obviously one thing that we wanted to do is try and minimise the amount of bushfire shutters because they're expensive. So one strategy we tried with this, which was very successful, was we've got 3 large openings with 8 different windows behind. And then along the bottom here, we've got the 3 large openings with the bushfire shutters protecting those 8. So we've saved those 5 bushfire shutters. And also you've got a usable space because they're little decks off bedrooms. So you can still get outside and use that space if you wanted to have the shutters down for heat or for another reason other than bushfire. Going into some of the roof details, we use a very simple roof construction. We use the Promatech tested system for the roof, and then the eaves had the similar sort of system and applied that to this raked ceiling as well. And then the walls, like I mentioned, was the Hardy wall sort of boundary system that we used on it. Things I've learnt, and it's been touched on quite a bit, is condensation in bushfire, and we've heard that's been looked at in more detail with the Australian standards as well. So this is a simple diagram that I think Mark Dewsbury presented a few years ago. But what the typical roof does is it brings the moisture in, it soaks the insulation, the ceilings deteriorate, and you get a lot of problem. But with best practice, we've got ventilation that runs underneath the roof sheeting and is stopped by our sarking and is allowed to dry out with enough ventilation. I know probably all pretty familiar with that. So that's something that I learned after this project. So in following projects, we'll be looking at how we can improve on that. And it's interesting to see that there's some more tested systems coming out, which was discussed as well. Just looking at some of the other strategies, obviously we put the pool location between the direction of bushfire and the property. You can see the formwork for the bushfire tank as well here. So, and tried to use natural elements of a dry creek bed in the landscape to then soak up all the stormwater in the irrigation trench later. And then included in that, we made sure in the landscape design to keep as much of the surrounding of the house free of vegetation and using concrete paths in proximity to the house. And then further away, there was some combustible elements, but we try to make sure that in the proximity was protecting the building. Also was important in the materiality of it, just to fit in with the natural bushland. So using the sandstone and the Core-10 really worked quite well and harmonious. And then just going through some of the rooms and how they were able to work with nature. That's a really important part of sustainable design, is being able to connect you with what's happening outside, and that these connections you're able to have from different parts of your house as well is really important. One of the most expensive parts of the house is that triangular bale flame zone window up there. It's about $6,000. So obviously there's a lot of cost in building in flame zone, but it was able to really bring in quite a lot of nice light. This is just going through some of the bedrooms and some images we've seen, and even internal spaces we brought natural light into, and a shot of the pool and then from the back. So that was my presentation, just running you through some of them. If you want to view any more videos of the construction, you can scan that, and have a look on YouTube, or happy to connect. But we'll hand back to Mark, I think.
Can you hand that to them? Thanks, Cory. I love that house. It's beautiful. You may not want to answer this question, Cory, but how much did that house cost?
1.65.
And when was that?
Finished last year.
There you go.
450,000. So slightly more, but more modest budget, but also more modest sort of size on that house. So
Can I clarify that though? Was that owner built?
no, so we actually had a builder do that project, although the owners actually did the hempcrete installation. So,
And I assume that would have saved a lot of money, the owners doing the hempcrete.
I think the money they saved certainly was spent on the Parhammer windows.
Yes, true.
I mean, they are beautiful and they're a quality product, but they're expensive.
I've got one question through the app for you, Kirsty, while you've got the mic, has hempcrete been tested to AS 1530.8.2 to your awareness?
I'm not entirely sure, so I'd have to have a look at...
Was that a 0.4 test you showed?
That the rating was like a FRL rating.
Yeah.
So it's got through the flame zone because it's better than a 30-30-30 rating, that 60-60-60. So I'm not aware of specific testing for that.
Cool.
I mean, the market at the moment, it's a small market, and the flame zone section of it's quite a small market. So perhaps as it grows, there'll be more appetite for testing.
Okay, so a question for both of you, whoever wants to go first. So how much do you think building to a flame zone cost in terms of percentage on the build?
Well, compared to no barrel rating, it was about 15% of the build budget was shutters and windows, extra linings on walls and that sort of thing.
Mm-hmm.
Look, I'd tend to agree that, having done a number of builds in BFZ, you could be anywhere from sort of 10 to 25% extra on top of your build cost. On this particular build in Blackheath, I'd say that the additional cost was about 15% as well. I think it's also, when you're designing in BFZ, looking at what are the expensive aspects, and a lot of those are windows. So being very careful in terms of where you put your windows and how you size them, and doing that as optimally as possible is one of the great ways of keeping costs down, and also simplifying things. Doing sort of the eaves and roof, the more complex the build is, the much more expensive it is because of the additional requirements for flame zone.
Yeah, I might just add to that from my personal experience. I just had a project fall over where my clients couldn't get finance. So basically the cost of the build was more than the bank would lend. And basically, obviously the bank's working on real estate costs, and spending that extra 20% on flame zone doesn't get you 20% more in value real estate wise. So in this case, it just couldn't happen. So it's really a big consideration. Question for both of you again. What were the hardest aspects to address in terms of meeting the bushfire building requirements? And did these adversely impact your sustainability credentials?
Well, the builder on this one, he came from a commercial background, so he was used to working with fire engineers and being able to do performance solutions, and there's not a huge market of people doing performance solutions. We've seen Kirsty's done one with hers. And so we had a lot of ideas that we wanted to test, but the certifier knocked it back. So and obviously we're seeing that with the Australian standard as well. It's getting more and more prescriptive, and which is good because we know it's going to perform well, but it's quite a small market of products that can be used, and less flexibility in what you can do in being able to achieve what you want. And so, for example, we wanted to use sort of folding Core 10 fins as bushfire shutters and as solar control But going down that path was going to be $30,000 or $40,000 of engineering and the like to go, and it was just, there was no appetite for that with the client.
I think also looking at things in terms of what's cost effective for the money that the client's putting in. So something that we would typically want to do in a colder climate like Blackheath is slab edge insulation. But in a BAL FZ zone, how do you cover your slab edge insulation to get your BAL FZ rating? So in this particular situation, we actually avoided that by having an exposed slab edge, and then we actually had insulation on top of the slab and a timber floor on top of that. So the clients got the thermal outcome they wanted, and we also met the BAL FZ, but it's really trying to think about what are we trying to achieve, and given that we have these BAL FZ restrictions, what is the most cost-effective way to actually achieve that outcome?
Okay, keep on the mic. So what would you do next time to improve sustainability and also the bushfire resilience?
I'd really like to cut the big pine tree down in the neighbour's yard because it was really awful for both solar access and in terms of flammability of that tree. I'd definitely like to do that. But in terms of the actual design, on that particular house, the roof was perhaps a little bit more complex than it needed to be, and that was something that was the client really liked it. But certainly from a BAL FZ point of view, really keeping roof lines and shapes and designs really simple is a great way to avoid build-up of debris, capture of embers, those sorts of things. So really simple, sort of straightforward things that you can sort of do in terms of the design right from the outset.
Yeah, I think I just last year did the Passive House course, so understanding that having that first floor was all structural steel holding up this amazing floating roof between all this amazing glass, all of that's thermal bridges, that's heat and cold superhighway into the house. So understanding that better means that I wouldn't use as much embodied carbon sort of materials as steel and concrete as much in the next project, and design those sort of thermal bridges out more in the next design in considering use of more natural materials, using timber and sort of vapor permeable wraps and those sort of things that are going to hempcrete are going to work a lot better.
All right. Might open it to the floor now. I might have to get you two to come up here while the mic revolves around.
Thanks, guys, for the presentation. It was really good. Cory, fantastic house, mate. I'd love to own that myself. Amazed at the build price of 1.6 on a sloping block like that. You know, with all the products in there, I know how expensive all that stuff is to do. That's really well done. Kirsty, question for you in regards to the hempcrete product.
Yes.
Economically, how does that stack up against a conventional sort of flame zone build?
So I actually got into doing the hempcrete for building my own hempcrete house back in 2012 to 2014. It did take me 2.5 years. But back then I actually did like an analysis of the cost of that particular build compared to the cost of standard building and then the cost of the walls. So at that particular time, it was about the same as brick veneer. So not as expensive as double brick, but not as cost effective as a clad home. Since then, building costs have gone up substantially, and the hempcrete is also gone up. So I would say that there's probably, in terms of that, probably like a 5 to 10% premium on your walls. But you've got to look at this. Your walls are only one small part of your actual build. The other thing is the increased thermal performance you get from the walls means that over the life of the building, you're going to have lower heating and cooling costs. So my first hempcrete house I built, which is on the New South Wales South Coast, it actually has no heating and no cooling, and it stays comfortable all year round. That's a combination of good solar passive design, the hempcrete walls, double glazed windows, good insulation, well-sealed building.
I also noticed on that sample you sent around how rigid the product is. How does that work as far as, as a builder, because we're always concerned about this, as far as your, expansion and contraction sort of issues?
Okay.
With things cracking up over periods of time.
So a couple of things. The material, yes, it is quite rigid, and in fact, usually because we put the roof on first and there's a timber frame, we still need to put bracing through all the walls. But they did some testing in France and actually found that the hempcrete as a bracing material actually worked better than either timber bracing or metal strap bracing. But you're asking about cracking like you would in a masonry building. If you have walls over about sort of 8 to 10 metres, you would need to provide a construction joint. However, the lime is much more forgiving in terms of movement than masonry is. So I'm trying to think of the technical term. It's a modus of elasticity. So it's about how much the material will deform before it cracks. And it actually really performs quite well, which is actually another reason why in earthquake areas it actually performs good as well. So yes, if you're having long walls, yes, put a construction joint in there, but it will perform better than your masonry will in terms of cracking.
Great presentations, both of you, and I think that hempcrete's a fantastic product. So I'm a builder, a building surveyor, and was BPAD up until last year. So a couple of questions for you about your hempcrete. How do you get past the fact that it's a performance solution, both in terms of the BCA and 3959? How have you addressed that?
But I think at the moment where I've used it in the Bal FZ, it's the 60-minute fire rating has got me through because of the minimum requirement to have a 30-minute fire rating. So in that way, it's not a performance solution for the 3959, but it is under the BCA.
Yeah, and it's not a criticism at all.
Yeah.
It's an amazing product. I think it's fantastic. I'm just thinking about, from the BCA, as you say, it's a performance because there's masonry. But from a 3959 perspective, how do we, if we've got a BPAD level 3, would have no problem signing off on it? Is that what happens? Is that what certifiers are asking for, BPAD level 3s to sign off?
No. As I said,
Okay.
The code mark certificate and that fire rating in the code mark certificate has
It's got a code mark.
Yes.
Oh, sorry.
That's what I was... So,
yeah, great.
yeah.
I missed that very important part.
That's all right.
You've
So
answered-
that 60-minute fire rating is actually in the code mark certificate.
Fantastic.
So
Thank you.
That's how we've got through.
You've answered
Bal
my
FZ.
question.
Thank you.
Can I just, before we move on, in relation to the question about costs, and Kirsty might want to add to this, if you're using a 30-30-30 system, then you're adding expense and labour to the build. Hemp, you're not adding anything. So even if it costs a bit more, by the time you go up to your 30-30-30 system, you might still be equal or in front.
Interestingly, actually, I should have mentioned this in my presentation, is that, so with the hempcrete, you're building the same whether it's no BAL rating or flame zone. The wall construction is exactly the same. The other great thing is normally in a wall build-up, you've got your rain screen, you've got your cavity, you've got your sort of vapour permeable building membrane, you've got your insulation, you've got your frame, you've got your internal. With the hempcrete, you've got effectively one product and you end up with a solid wall. So no embers are going to get into that cavity because there is no cavity.
Thanks for both presentations. The hempcrete looks amazing. Just wondering, has it been tested at all to 1530.8.2 for use in that 10-metre flame zone scenario?
No. Look, in terms of that, I think it will perform well and I think it will pass, but it's about the companies having the demand in that market for them to justify paying for the cost of that. At the moment, it is quite still a niche product. I'm doing my best to make it a widely known and available product. But until then, that's a very, very small market. That's right.
It looks like that's a wrap and you get an early mark. You might be the first ones to line up for lunch. So, yes, thanks very much to Kirsty and Cory for presenting. And yes, please go out and sell hemp to the world. Maybe I should rephrase that.